Thank you very much for speaking with Design News, Sasha. I appreciate
Thank
your
you,
time
Daphne.
today.
I appreciate it as well. Looking forward to chatting.
Thank you. Can you explain your mission with bluShift?
Yeah, our company is working on developing a type of rocket propulsion that is at the core of it, about a quarter of the cost compared to traditional rocket propulsion systems. Uh, Easily manufacturable and in many applications reusable. And doing this all while at the core of it using a proprietary solid fuel, which is bio-derived and happens to be non-toxic, which is somewhat unusual in the rocket world.
Yeah, that's excellent. I did see that on your interview with CNN, where I learned a little bit about your bio-derived fuel.
Hmm.
Um, and I think you mentioned it was made of agricultural products.
Yes,
Um, can you explain a little bit how your engine works since it's using a different type of fuel?
sure. It's what's called a hybrid rocket engine. So this technology and concept has actually been around for about 100 years. But the idea is it's sort of a combination of solids and liquids. In our case, the fuel is solid, and it's inside our combustion chamber, and the oxidizer is a liquid, and it's injected uh, into the center of our fuel and burnt from inside out. So, unlike your sort of like Estes rocket, solid rocket motor, where you or like fireworks, you light it, the fuel and the oxides are all powder, liquidy, and combined together. And once you light it, it's going, it's gone. There's no stopping it. In the case of hybrids, you have the ability to do multiple things. You can stop it, so that's good in case of something that's an emergency. But you can also throttle down or throttle up how much oxidizer you provide, which allows you to create more or less thrust. And one of the reasons that folks might choose this type of technology is when you look at the ones that most really have the most heritage, solid rocket motors, like your Estes rockets or the boosters on the side of the shuttle way back when. Or on the other side, you have liquid rocket motors, which is combining pretty explosive combination of gases and liquids. Uh, Both of them come at extreme costs. Uh, on one hand, solid rocket motors are really simple. So the concept of how they work is really easy. The downside is once you start scaling them, they get exceptionally dangerous. It's virtually like having a TNT, and when you produce it, to produce it very carefully, or literally your production plant can go up and big boom, which happens. On the other side, you have liquid rocket engines, which are very complex um, and very expensive, exquisite to build, but extremely good performance. And what sits in the middle are hybrid rockets. It's far less likely to explode on you. If you choose your fuels and oxidizers correctly, they can be non-toxic. And the R&D, that sort of incredible R&D that's cost associated with getting to a point where you have a usable rocket engine is phenomenally less. That's part of the reason. That's why we chose it. Is it's sort of this interesting fit of um, what is the mission? What is the need of the customers? Well, I need to get something from here to up to there, or something from here over to there. And looking at it from a business perspective, you look at it, well, what type of propulsion will do that at the lowest cost? And that's really how I came to hybrid rocket. That's how I chose hybrid as our go-to choice. And you see this now more and more frequently, less in the US, but more in other countries where I think they're looking at it from less from a heritage way of like, well, we've always done liquids or we've always done solids. Like, well, we want to get to space. And whether it's Germany, Australia, South Korea, um, and other countries, they're using hybrid rocket engines. In the United States, we're one of just a handful of companies doing hybrid rocket engines, and we're the only one doing it with a bio-derived non-toxic.
Okay, excellent. And so can you explain a little bit? Are you building the propulsion system for your own rockets or a system that other rocket manufacturers, could obtain from you and then use for their own, or both?
So so both is the short answer. So we originally our plans were just to provide the service, both suborbital launch services to take experiments and research for developing products to be used in space, up into space and back down again for longer than the competition would. That's still something we're going to do. And but we also saw a bigger opportunity to sell our engines to replace solid rocket motors, which are incredible short supply. They were incredible short supply 3, 4, 5 years ago, and in this very moment in time, it's even made the mainstream media in terms of being exceptionally short supply. We can't manufacture them enough. The raw materials in short supply, and it turns out to be an exceptionally good time in history for us to come to market with a different capability that can replace solid rocket motors in a lot of different cases. So we would sell our engine to replace, what we're principally going after is not selling our engines to be used as orbital class, take a payload to space, but something you would strap something else to. Like you could theoretically put our engines in clusters around a orbital vehicle to give a little more oomph, to take a little more payload to orbit. Or the market that we're specifically going after, which is enabling tests for defense use or for commercial use, where you need to get some capability up to a high velocity in the atmosphere to replace those solid rocket motors, which you can't get for about 12 or 18 months, with our capability, which not only you can get in a shorter time frame, but you can also do it at a lower cost, 1/4 of the cost. And importantly, ours can also be reused if it's enabled with a recovery package, parachute and other systems. We can recover it, refurbish it, get it back to the customer for 1/10 of the cost of the original cost to us.
Okay.
So those are the markets we're going after. So it's the both.
Right. And so in addition to using the biofuel, which could be looked at as, sustainable, you also have recoverable parts to this?
Yes, we from the get-go, and that's part of the heritage of wanting to do doing launch services. We from the get-go knew that we want that it totally changes the financials if you can recover your engines or most of your engines, right? But from the get-go, remember I talked about doing things like an engineering exotic way where you have exquisite liquid rocket engines, and SpaceX is like the most important, probably the most prevalent example, right? Exquisite engines, exquisite capability, exquisite landing capability. And all that comes with an incredible amount of initial investment costs and research, and it's beautiful from an engineering standpoint. But we're treating this like a business where we want to get to market fast. We want to do recovery simply, and we want to do propulsion simply, so we can produce it at lower cost, produce it faster, not need exquisite machines to produce it, and enable a lower cost on an ongoing basis to our customers because they can potentially reuse it should they choose that capability.
Excellent. And you mentioned that now is the right time to go to market. I remember from that previous interview, you mentioned that you're aiming to replace some nano satellites that are ending their service in orbit. Is that one of the aspects that makes this a good market, or are there other opportunities that you see?
Yeah, so we're no longer focusing on the launch small satellites to orbit market. Instead, we're looking at the opportunities that are in front of us in really the immediate future now, where we can replace a desperate need for boosters, a need for rocket boosters, with something that can get something up to a certain velocity. And the United States is incapable at this time to produce enough solid rocket motors to do that. And so we see that as a fantastic opportunity for us as a company that has a never before seen capability and alternative. And I think what makes us particularly different is that we've developed an engine that's of a particularly significant capacity. These are some of the larger on a solid rocket motor. This is on a larger size capability, not the size of the boosters that strap onto the shuttle, but in terms of missile defense and interceptors, these are engines that are on that dimension of those sizes, where you're taking out something to stop an incoming missile, for instance. Now, do I think our engine might be used for it? Maybe, but I think for us the biggest opportunity is helping other companies inexpensively test their capability with our booster in a way that's more sustainable, easier for people to use, safer to be around, faster to get, and far less expensive, which means lower cost for our customers, lower cost for taxpayers often, and relieving a lot of the pressures on the supply chain for solid rocket motors.
Excellent. So how have your latest tests gone?
Oh gosh, it's been so we had a test just a few weeks ago this was a mixed bag. We ran a couple of experiments that were high risk, high reward, and a couple of them worked out, and a couple of them didn't. Some of them exacerbated some issues. So, in fact, in the background right now, my engineering team is talking through some of those issues and how the next test is going to be designed. So, it's just like any sort of development program, when you develop any rocket engine, you got to experiment, you got to fail. The good news is that this particular test, we had a number of wins and we had a couple of failures, and they were very instructional. So we're very much looking forward to the next test. We believe that with just a handful more of tests in this particular engine, we'll be able to make a flight-ready version of it, and then we believe as early as 12 months from now, be able to launch our very first commercial one with a partner.
That's great news. Great news. Excellent. Do you have any final thoughts that you'd want to share with your fellow aerospace engineers working in the field?
Yeah. Well, sure. I think the big thing is keep an eye on us, and we're going to be hiring more people. And so, so for the people in the field, we'd love to have other people join us. Is probably one thing I would say. The other thing is that for other folks that are reliant upon solid rocket motors in their businesses today, to reach out to us. We're working with a couple of different companies that are looking at different scales of our propulsion system being used for different applications. And the capability, I think, is to be ultimately truly revealed, and the opportunity to dramatically save on the costs, and more importantly, get it to the customer faster, is something we think will prove a reality within the next 12 months, and it's an exciting time. And so I hope that there's other folks in our industry that once they see the credibility of the engine in performance in a flight application, besides our small engine that we used years ago and flew, I'm hoping we can be part of the solution to solve the supply chain shortage, which I don't think is going to be relieved for many years here in the United States.
Okay, excellent. Well, thank you for your efforts. I appreciate it.
Thank you. Thank you, Daphne.
Thanks for your time.
Talk to you. Sure.